Welcome, dear students, to a new session. Today, we'll be working on adding and subtracting algebraic fractions. In adding and subtracting algebraic fractions, same rules of adding and subtracting fractions apply, where to add and subtract fractions, you need to have the same denominator. And when I succeed to have a same denominator, I only add the numerators together and I don't change the denominators. What if we don't have same denominators? Yes, we try to work out to get a common denominator. Let's check and see how will we do this. As you can see here, the two denominators are the same as f2 of x and f2 of x. So when we add, we write the denominator as it is while we add and combine the two numerators. Same thing applies in subtraction. Let's check example 1. In example 1, as you can see here, x over x plus 4 plus 4 over x plus 4. Yes, they have the same denominator. So as long as we have the same denominator, we can start by adding or subtracting. Here, the question wants us to add. So we're going to add the numerators together as x plus 4 over x plus 4, which is equal to 1. What if the two denominators are not the same? As you can see here in n1 of x and n2 of x. In this case, you're going to multiply each denominator up and down in the other fraction to get the common denominator. So here you have the first fraction has a denominator of f2 of x, multiply up and down here by f2 of x, and this one f4 of x will multiply up and down here. So here it will be f1 times f4 plus f3 times f2 all over f2 and f3. Same thing goes with the subtraction. f2 I multiplied here up and down, f4 I multiplied here up and down. So it's f1 times f4 minus f3 times f2. And the denominator, we write it only once, which is f2 times f4. Let's see an example. Here, do they have same denominators? No. So we're going to multiply x plus 4 in the other fraction up and down. And we're going to multiply x minus 1 in the other fraction up and down. So it will be like this. See, x times x minus 1 plus 4 times x plus 4 all over x plus 4 times x minus 1. If you simplify this, it's x squared minus x plus 4x plus 16. So it will be x squared plus 3x plus 16 over x plus 4 over x minus 1. Let's move on to example 3. Here, in example 3, we have two algebraic fractions, and the question wants us to add them together and to show the domain. Let's see it together. Let's write the question. The question is asking you to find n1 of x plus n2 of x, so we're going to write them plus each other. After that, we're going to factorize any of the numerators or the denominators that can be factored. So here we can take x as a common factor, and here it's a difference of two squares, x minus 2, x plus 2, and here it's x open bracket x plus 2. Before you combine, before you simplify, before you cross out, you need to check for the domain. So in this case, the domain is all real numbers except for the 0, the negative 2, and the 2. If you check it here, the domain is all real numbers except negative 2, 0, and 2. After that, we can cross out the x with the x plus 2 with the x plus 2. So in the first fraction, it will be 1 over x plus 2 plus the second fraction 1 over x minus 2. So in this case, I don't have the same denominator, then I need to get the same denominator. How will I do this? I will multiply x minus 2, which is the second denominator in the first fraction, up and down, and I will multiply the x plus 2, which is the first denominator in the second fraction, up and down. So it will be x minus 2 plus x plus 2 all over this one in here. If it can be simplified more, it will be 2x over x plus 2 times x minus 2. In example 4, I have two fractions. The question is asking me to get their sum. So here, I need to factorize each of the expressions that can be factored. So this one is factored into x minus 2 times x minus 3, where here I can take 2 as a common factor over x minus 2 times x plus 3. Before you cross out, before you simplify, before you combine, you need to find the domain. So the domain in this case is all real numbers except for the 2, the 3, and the negative 3. After we get the domain, now we can go simplify to be able to get the same denominator in order to add the fractions. So here, the x plus 3 is crossed out to the x plus 3. So in this case, I will multiply up and down by x minus 3 in here in order to be having the same denominator for both fractions. So we multiply up and down here by x minus 3. So we now have the same denominator, and then we can add 3x minus 4 plus 2x minus 6. If you simplify this more, it will be 5x minus 10 over x minus 2 times x minus 3. Check for the common factor. 5x minus 2 over x minus 2 times x minus 3. Cross out the 2x minus 2. So it will be 5 over x minus 3. Let's now move on to another example, which is example 5. We have two algebraic fractions added together. The question is asking us to simplify it, find the domain, and then find n of 0 and n of negative 1 if possible. First of all, we check for factoring and simplifying the expression. For factoring the expression, here are the two expressions. This one, we just need to arrange it first as negative 4x squared plus 2x. So we'll take the negative outside the bracket and change the signs of inside the bracket. So this negative sign has changed this plus sign into minus. So 12 over, I can take the 3 as a common factor, 4x squared minus 1 minus 2. Take the 2x as a common factor, 2x minus 1. This can be simplified more as what? Yes, as difference of 2 squares. So, and the 12 as well can be divided by 3 as 4. So 4 over 2x plus 1 times 2x minus 1 minus 1 over x times 2x minus 1, as the 2 is crossed out with this 2 as well. Now check for the denominators. So we'll multiply here this whole fraction by x up and down, and we'll multiply this whole fraction by 2x plus 1 up and down. Okay, but before we do this, let's check for the domain. Don't forget the domain. The domain is all real numbers except negative 1 over 2, positive 1 over 2, and 0. Okay, so as I said, we'll multiply this fraction up and down by x, and this fraction up and down by 2x plus 1. The denominators are now the same. Let's find the numerators. 4x minus bracket, don't forget that. So it's 4x minus 2x minus 1. Okay, simplify this more. It's 2x minus 1 over the whole denominator. So 2x minus 1 will be crossed out with the 2x minus 1. So it's 1 over x times 2x plus 1. The question is asking you to find n of 0. Actually, it's not possible as 0 is here, so it's not in the domain. N of negative 1, yes, it's possible. I go to the simplified fraction, easier, faster to find n of negative 1 by doing what? Yes, by substituting each x value by negative 1. So I find an answer which is x equal 1. Let's move on to example 6. In example 6, the question is asking me to add these two algebraic fractions. First of all, check for simplifying each fraction. So the first one as it is, the numerator we cannot factor it more. The denominator we can make it as x minus 3 times x minus 2 plus, yes, excellent. This numerator we can take 2 as a common factor, and in the second denominator we can factor it as x plus 3 times x minus 2. Before we cross out, before we simplify, before we get the common denominator, as you all know that we need to go and get the domain. So the domain in this case all real numbers except, yes, except what? Excellent, except the negative 3, the 2, and the 3. Now, as you can see here, the x plus 3 can be crossed out with the x plus 3, so it's 3x minus 4 over x minus 3 times x minus 2 plus 2 over x minus 2. Yes, you're now thinking correctly that what shall I do now to find the common denominator for both fractions in order to be able to add? Yes, we're going to multiply the second fraction by x minus 3 up and down in order to have the same denominator. So this will be equal to three x minus 4 plus 2 times x minus 3 over x minus 3 times x minus 2. To simplify it more, so it's 3x minus 4 plus 2x minus 6 over x minus 3 times x minus 2. Combine the like terms in the numerator. It's 5x minus 10 over x minus 3 times x minus 2. If I can take 5 as a common factor, so it's x minus 2 over x minus 3 times x minus 2. So it's 5 over x minus 3. Example 7, the question is asking us to simplify this algebraic expression by adding the two fractions. Same rules apply, same way apply, that we need to have the same denominator. Before we do this, we factorize, we state the domain, and then we get the same or the common denominator. So the first numerator cannot be factored. The first denominator can be factored as 2x minus 3 times x minus 5 plus x plus 3, and here you can have this negative outside to arrange it more. So negative 2x squared minus 15x plus 18. Don't forget, when you take the negative outside, you change all the signs. Can this be factored more? Definitely yes. X minus 5 over 2x minus 3 times x minus 5 minus, because this minus changed this into minus x plus 3, and this can be factored more as 2x minus 3 times x minus 6. Yes, before we simplify more, before we get the same denominator or the common denominator, we need to find the domain. So the domain is R except, yes, except what? Excellent. 3 over 2, 5, and 6. After that, as you can see, we can cross out this x minus 5 with x minus 5. So what we'll have it here, it will be 1 over 2x minus 3 minus x plus 3 over 2x minus 3 times x plus 6. Can we subtract now? Definitely no, we cannot subtract now because we need to have the same denominator in both fractions. So we'll multiply this fraction up and down by x plus 6. So for the first one, we'll have x plus 6 minus x plus 3 all over 2x minus 3 times x plus 6. To simplify it more, it will be x plus 6 minus x minus 3 over 2x minus 3 times x plus 6. So in this case, it will be minus 9 all over 2x minus 3 times x plus 6. You guys are wonderful. You guys are great. You have done a great job. Thank you very much. See you in the next session.